Assalamualaikum and greetings to everyone. My name is Nur Fakira Adrana with the matrix number 202552.
Hi, my name is Siti Nur Fatihah binti Rozaidi and my matrix number is 202934.
Today we are going to talk about the applications of graph.
Okay, so let's get started. Applications of graphs. We will start with the introduction of the graph. A graph is a structure that contains vertices or nodes, and each of the related pairs of vertices is called an edge. The edges may be directed or undirected. As you can see here, directed means one direction, while undirected means two directions. To give you a clear and better understanding, I can show you with the diagram here. And for example 1, this is a simple graph, and this is what we call vertices or nodes. It can be represented by an individual or organization or others. And then the line that connects the vertices between each other is what we call edge. And then if we have another edges that link to the same vertices, it means that an edge that connects to a vertices itself is what we call loop. But here in the diagram there are no loops. And then going to the example 2 for figure 1, this is undirected graph. As I said earlier, undirected graph means the edges only have two directions. For example, we can say that this vertices is a person. We can say that if person A can shake hands with person B also can shake hands with person A, because there are two directions. A can go to B, B also can go to A. And then for figure 2, directed graph means it only have one direction. As example, we can say if person A like person B, but person B may not like person A, because the edges is a directed graph. It only have one direction. Only A can be linked to B, but B cannot be linked to A. You clear? I think that's all for the introduction. Then we can go on to the application of graph. Graphs are used to model social structures based on different kinds of relationships between people or groups of people. These social structures and the graphs that represent them are known as social networks. As you can see here, we can solve many problems using graph models. And this is one of the applications that can be used by graph, which is social network. It says here individuals or organizations are represented by vertices. This is vertices, and this that represented by individuals like Paula, and the relationships between individuals or organizations are represented by edges. This is the edges. The line that connect Paula and Eduardo. And we can say here that Paula may be friends with Eduardo, and Eduardo also can be friends with Paula. And then here we can use Facebook as the example for social network, because Facebook is very famous nowadays. And we can use simple graph to represent whether two people know each other, whether they are acquainted or friends in the real world or the virtual world. Each person in a particular group of people is represented by a vertices. As you can see here in the diagram, this is simple graph that we can model as a Facebook friendship in Facebook. Easy to say, it's like friendship relationship in Facebook. We can model it using a simple graph. Each person represented by vertices, and then undirected edge is used to connect two people when these people know each other or friends. that, like I said earlier, Paula friends with Eduardo and Eduardo also friends with Paula. No multiple edges and usually no loops are used. In this simple graph, there are no multiple edges and also there are no loops. And then the next application that we can use, we can use graph to apply in information network. Graphs can be used to model various networks that link particular types of information. Example is the web graph and also the citation graph. Okay, the example that I will explain on information network is what we call World Wide Web or the web graph. The World Wide Web is we often use in the internet, which is the www. The World Wide Web can be modeled as a directed graph. So you can see here the edge only have one direction. That is why it's a directed graph. And then each web page is represented by a vertices. This vertices is represented by a web page. Or as you can see here, this vertices is called weather.com. This is the web page. And then an edge starts at the web page A and ends at the web page B. Is there a link on A pointing to B? I will show you here like this one. This web page is pointing to this web page. So it means that this edge starts at web page A and end at web page B. And then the new web pages are created and others removed somewhere on the web almost every second. So the web graph changes on almost continual basis. As you can see here, we often use the internet. When we use internet, we will open many tabs or many web pages. So this graph will change continuously every second. For 1 second, it may look like this, and for another second, it may look like others.
The interesting part and powerful features of graph is that we could use it as a modeling structures. By that, we could capture the crucial part of the features of the application. That's why graph models are intensively used in the study of transportation network. It plays a crucial part for the communication structure such as air, rail, and other network that requires transport system. Example of graph models being applied is mixed graph in road network and directed multi-graph in airline route. The first example of transportation network is airline route. The air transport network modeling purpose is for the airline companies to organize their routes in a cost-efficient way. That's why graph model is often broadly being applied in the study of air transportation network. It is to show a number of links between airport station. So how could we see the graph model being applied? It could be seen by when each airport station acts as a vertex, and all particular flight by certain airline will act as a directed edge that going from the vertex of departure airport to the vertex of the destination airport. It could be seen by the example figure on the right side, which shows that Detroit acts as a vertex, and the directed edges that going from a vertex of departure airport, which is Detroit, to the vertex of destination airport, which is Newark. Let's take note that we could also use a directed graph without multiple edges if we are only interested in whether or not there is at least one link from a vertex to another vertex, which is the destination or airport. The next example of transportation network is the road network. The ways of modeling a graph on a road network is by representing the vertices or the vertex as the intersections, whilst the roads act as the edges. There are a lot of types of graph models being used in this network, such as directed graph, simple undirected graph, and mixed graph. Simple undirected graph is used when all roads are two ways and not more than one road connected with two intersections. Mixed graph is applied when there was road which is one way or more than one road is connected with two intersections. For example, a transportation network, a road network, which is Google Maps, shows that a graph model being mainly used as an edge-weighted directed graph. But it also shows some other types of graph model as well. The main functions of Google Maps being used is to shoot for the shortest path from one vertex, which is the current location, to every other desired destinations, which can be implied as in single source shortest path variant, which is also considered as a directed graph. Now, we will go to the next applications of graph, which is the last one, the software design application. There were two models being introduced in these applications, which is the model dependency graph, which also known as MDG, and precedence graphs and concurrent processing. Now, I will explain to you guys one of the graph models being introduced in this particular application, which is module dependency graph. The module dependency graph consists of finite set of vertices, a finite set of hardware edges that connect one vertex to number of children vertices. This MDG helps in terms of understanding the different modules of a program interact. Thus, module dependency graph is used in a program to analyze the structure of a certain program that a creator helped design. So how it works? The graph model could be seen when each module acts as a vertex, and then the directed edges from module to another module is made if the second module depends on the first module. This is example of a web browser graph model. So I will explain to you guys the examples of software design application, which could be seen in a graph drawing tool, which is dot program. So how could dot program apply this particular model? Graph model will use files as modules and a directed edge between two files, which is two modules, if the code in one file refers to a type, variable, function, and macro defined in the other file. Once layout finished, the program will then use a user-specified output format directed to a file, for instance, a PostScript, and GIF. This is examples of the MDG of the dot program, which we could see that the file is used as a modules, and the directed edges consists of two files in one. The connection between two files, if the code in one file refers to type and etc., is considered as the directed edge. So we have come to an end of our presentations. As a conclusion, graph is used in many applications and has a wide variety of graph model as well. Each of it brings its own functionality and shows different structure. The applications of graph model may not seem to be a crucial part in our system, but it does play a big role in terms of a real life, especially used in computer science. Graph model also provides a remarkably simple way to categorize the complexity of ecological networks. For instance, graph model is also being used for the communications network to link devices for calling functions. That is all from us. I hope that you enjoyed our presentation. Thank you.